Okay, example number 2. First thing to recognize is this is a Y delta load. Let's consider that up in here, this is all A right there, and down here, this is all B. There's no line impedances, So therefore, what we see is that AB on this side, going from here, AB down to the B there, is equal to the voltage on the AB on this side, right? From VAB, from the plus to the minus, that's getting us from here to here, right? They share the same nodes on the outside. But because this is a delta, right, V line in a delta system, V line equals V phase. So if I have to find the per phase powers, then what I can remember is that if I know that load side phase power, that is that EAB, which is the phase on the right side. So first step, I want that EAB, which is line, and we're looking at the Y, right? So this is EAN. This is the Y source side to get to the big A, big B, square root of 3, angle 30. Plug that in, 120, angle negative 30, root 3, angle 30, and that comes out to 20, technically 7.85. You could just call it 208 volts, angle 0 degrees. So that is my source side line. That is my load side line, which is VAB, which is equal to my load side phase, which is VAB again. But if we're going to call that of a phase, I can also call it V of a single phase. So now once I know that V of the single phase, V equals IZ, I equals V divided by Z, that VAB over the ZAB is my IAB, which is the I of a single phase. VAB is 207.85 angle 0 divided by 12 plus J6. Don't forget those J's still. That's still true whenever we're dealing with AC. And that comes out to 15.5 amps, angle negative 26.6 degrees. So now using my favorite law, or not my favorite law, my favorite way to get complex power, VI complex conjugate. We're looking on all of these single phases, right? Which is the phase on a delta is AB. I, AB, complex conjugate. That V, 207.85 volts, angle 0. That I, 15.5 amps, angle positive, because we did the complex conjugate, 26.6 degrees. And my S of a single phase comes out to 3.2 kVA, angle 26.6 degrees. And now I have my S without the vector, which is apparent power of a single phase. I go from polar to rectangular. If your calculator was spit out in rectangular, then just go back and forth from rectangular to polar. But either way, we want both of these parts, 2.88 kilowatts plus J 1.44 k var. And now that 2.8, that is my P of a single phase, and this is my Q of a single phase. The video is getting real laggy, I'm realizing. I'll let it catch up just a little bit. Okay, so now we found the per phase powers, and then we want the totals. So I just multiply each of these by 3. And my S apparent power total comes out to 9.66 kVA. My P total comes out to 8.64 kilowatts. And my Q total is equal to 4.32 kVAR inductive. It's as easy as multiplying by 3. Just find the single phase and just think, what is the phase? In a Y, it's AN. In my delta, it's AB. Phase voltage is across the element being what's on the load side. That was part A, this was part B, and then part C wants us to do it with these line equations. So let's just think about what are these terms. Root 3, it's just the magnitude here, but the V line was our V phase on the load side. Right, I'll write these in because that way we see what we're plugging in. But the root 3 V line is 207.85 volts because the V line equals the V phase on a delta side. And then I line, well, this is what we don't have here, so we need to solve for it. And I line on a delta, this is from the delta side of the equation sheet, I line equals I phase root 3 angle negative 30. So I multiply that I phase of 15.5, multiply it by root 3, excuse me, this is vectors, so it's 15.5 angle negative 26.6, root 3 angle negative 30, comes out to 26.83 amps, angle negative 56.6 degrees. So right here, that is the I line that's going to go over there. 26.83 amps. Erase this. And my S total comes out to 9.66 kVA. Oh, would you look at that? It matches the S total that we found in part B. Then I can do the P total with that same equation, root 3, the magnitude of V line, magnitude I line, cosine theta. So the only tricky part here, same angles or the same numbers as before, 26.83, but that cosine is going to be of, let's highlight in yellow where it's coming from. We'll grab it right here. 26.6. And that's because it is the theta is from the phase, which we talked about in the concept discussion, but that's where it gets a little confusing. Q totals, going to do the same thing. V line, I line, sine theta, root 3, 207.85, 26.83, sine of 26.6. And when I do each of these, comes out to 8.64 kilowatts and 4.32 kVAR inductive. Matches part B.